Hi again, guys. This is section 6.3 and I'm going to do my second example of sketching a transform logarithmic function, which is number 13D on page 340. So I've written down the function here, and remember that before we go ahead and do our mapping notation, we want to make sure to, sorry, just getting a different color here. Want to make sure to factor out that 1/2. Be careful that you do it carefully and if necessary with a calculator so you get the right number for the horizontal translation. This is a common error that I see all the time, especially when we're factoring out a fraction over here. So really do that part carefully because that will throw everything off if you don't do that part properly. Okay, let's go straight into getting our mapping notation. So we now have the 1/2 value that we pulled out of the bracket affecting the x value, but remember it has to be reciprocal, so that becomes 2x and then minus 6, opposite sign for the horizontal translation, and then negative 2y minus 3 for the y value. So this is my mapping notation, and remember that we always want to also write down where the how the vertical asymptote has been affected. So vertical asymptote for my basic y equals log x is x equals 0. And since I have a horizontal translation of 6 units to the left, it is going to become x equals negative 6. Anchor points for y equals log x are 1, 0, 10, 1, and 100, 2. Apply the mapping notation to those points, and those points are transformed into negative 4, negative 3, 14, negative 5, and 194, negative 7. Okay. I'm just going to go ahead onto the next page to do the sketch. Nice big grid here, x-axis, y-axis. So my points are negative 4, negative 3, let me start with my vertical asymptote, which has moved to x equals negative 6. Since I have to go all the way up to 194, I'm going to make that pretty close to 0 over here. So that's going to be negative 6. And then my next point is negative 4, negative 3, so that's going to be really close to my asymptote over here. Remember that you don't have to have the same scale on the x-axis and the y-axis, and in fact you wouldn't be able to in this case because the x value goes up so high, but the y values are fairly close together. So I'm just going by ones on my y-axis, but I'm estimating much bigger jumps on my, did I say my x-axis? I meant I'm going by ones on my y-axis. Sorry, I don't know what I said. Can't remember. Okay, yeah, like I always say, that's what happens when you get old. Anyway, so we're up to 194 on the x-axis. So my next point is 14, negative 5. I'm going to put that somewhere over here. It's just slightly more to the right than my negative 6 was to the left of 0. So that's 14. Remember, this is a sketch. It's a sketchograph, right? So it doesn't have to be exact, but it should be representative, properly representing the situation and the shape of the graph. And then 194 I'm just going to put all the way out here, even though it's probably further than that, but I don't have any more room, so that's where I'm going to put it. And it's 194, negative 7, so somewhere down here. And now I need to connect these points. Yeah, it's a little tricky, but it looks something like that. Okay, should be easier to do on a paper. Couldn't make it as smooth as I wanted it to be, but close enough. Get the idea, right? Okay, so that is the method that I would use to sketch transform logarithmic functions. They use a different method in the textbook where they apply each transformation one at a time. That is fine too. As usual, I don't mind if you use different methods as long as you do everything correctly. I don't have a problem with that, as you know. All right, guys, have a great weekend, and I will see you in virtual reality on Monday.